Three key ratios. So it's another advent of code problem. But this here it's this, but this time it's this here. And we've been doing this here, and it's been pretty fun so far. But this one has been a standout. And it's because of how well it and how beautiful its solution is, especially in array languages such as Uiua. And I'll be doing part one because it's pretty simple, and I think doing part two will make the video pretty long, but I've solved it as you can see. And yeah, I hope you enjoy this. So here's the input. I already pre-typed it in. And so first of all, let's parse it by line. Pretty simple stuff. So we'll have I, then we'll partition. We will partition on the new line characters. That would be. Then we'll parse on our new line characters. It should be that not equal to. Now we'll have a mask. If we want to partition over, let's partition identity. We can do identity here because we know it's a square matrix. It will have the same length for all of the rows, so we don't have to worry about turning them into pointers. And it should be a good first step. It's good enough. So what do we want to do with our P? So first of all, the problem states here that I should have actually read the problem first. So there'll be symbols, and then you need to get all of the numbers adjacent to any symbol. So like asterisk here is adjacent to 35 and 467. 63 is adjacent to this hashtag. 617 is adjacent to this asterisk. Then you get all of those numbers, then you add them. That's the part one. So the numbers we won't be adding here would be 58 because it's not adjacent to any symbol, including the diagonals, and also 114. It's also not adjacent to any. Okay, so first of all, really helpful part here is if we find all of our symbols. And since we don't really know what the symbols are, an easier way to do it is we look for all that is not symbols. So it would be numbers and the dots. Let's create that array. So it should be range 10. That would be the numbers, but these are not characters yet. So we just simply add them to the character 0. That would turn them into characters. And since it's an array of characters, it's a string. And then we have to just join the dot character. This would be the arrays that we will check membership for. And if we flip this and check for membership on every row, forgot to do that. Okay, what would the problem be now? Okay, looking better. So this would be the everything that's not symbols. So we simply just negate this. We can do the not here or outside, but it's cleaner this way. So these would be all of our symbols. So now we have a map of our symbols. So now why did we get this? Remember, we have to check for adjacency. And the good way to think about adjacency is of rotations. So if we rotate this up, if we rotate all of these by up by 1, and then we add it to the original, or wherein we just rotate with 0, okay, we'd actually get the adjacency with the upper cells, like 1, and then rotated by 1, so this will turn into a 1, right? Now if we do all of those rotations for like a left diagonal up, right diagonal, blah blah blah, all of 8 directions, and we add it to the original array, okay, we'd get all of its adjacencies. So let's try to do that. So let's think about it this way. So the rotations we'd want to do would be like 8 rotations, right? Because it's one for the cardinal direction, the one for the omnidirections. So that would go. So that means we'll have a 3-3 range of these guys. Oh, actually 9. So that will be including the 0 or no rotation. So This, we can think of it as a 3 by 3, the range, or like multi-radix, parang 0, 0, 1, 1, 2, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. And if we subtract 1 to this would be our rotations. So we'll have a -1 rotation, -1 rotation, which is basically -1 vertical, then -1 horizontal, -1 vertical, 0 horizontal, -1 vertical, then 1 horizontal. One positive na rotation would be on the left, to the left. The negative na horizontal would be to the right. Negative na vertical would be downwards, and positive vertical would be upwards. So if we do that, then we combine these, or like we turn this into like we say na kanang all of these ranks, all of the kanang rows would be rank 1 arrays. Basically turn this into a two-dimensional matrix. Okay, we can use this to rotate. So if we do a row rotate using this function over this array, but since we don't want to do this by rows, we have to fix our first array. And this would make it so that our rotations would apply on the entire matrix. So if we do this, we should get all of our rotations. And now if we do a folding max over all of this, and we get our adjacency. And that's because, again, these rotations, if we combine all of them, okay, we get all of its adjacent cells. That's very neat. So now that we have this mask, we actually just want to apply this to our original string. And whenever it collides with the number, we keep that number. But we have to make sure that when it collides twice, it only detects it once. Right? So look at 35 here. It technically collides twice with our symbol, but we only want to detect it once. And a good way to do this would be to turn this into lookups, or like a table lookup. So instead of we having number 467 here, in that cell, okay, we'll have its index. So like we'll have, say, zero, like ones, 111, and then whenever we encounter a 1, we just remove duplicates, and then we'll get the 1 from our table or all of the numbers, right? So first of all, let's clean it up, and I'll clarify what I mean by this. So now this one should be our mask. So let's call it that mask. Let's create our number list. So let's see, n. So n should be, we don't even have to take the parse input. We can go from the start. And then we can do a regex here, and that would work. So not that much of a fan for regex, but it works really well here. So we regex there, and we shaped it to give us that, and then we parse on the rows. Do I have 2 row? Yeah, I do have 2 row. So just row parse. Now we have numbers, table of numbers. So if we replace our characters here with like 1 index, and the reason where we're doing it with 1 index is so that we can turn the dots into zeros, and then that would be easier to deal with. So we want to turn these into 1 index, and we want every every sunod na number would be an increasing. So it's progressive. It's a progressive index. So this would be 111. This would be 222. This would be 3 3, and then 4 4. So let's go back to our parsed input. Oops. Now again, we look for our numbers. So it should be per row. We'll check +0, like plus character 0 on range 10. Membership. Now these would be all of our numbers. Now since we want this to be progressive index, the way we can do that is we check for only the first occurrence of these. And a good way to do that is joining 0 on the first of all of them. That way to know if a number begins, we just check pairwise if there's a 0, 1, right? Because that's the only time a number begins. Like 1, 1, that means it's in the middle of a number. 1, 0 means a number is ending, and we don't care about that. We only care about the 0, 1s. Now we can do a window 2. Then this would be window 2s. Actually, let's do it outside, so it's much easier to tell what's happening. So row window 2. Tapos we'll only get 0, 1s. We want to only get 0, 1s, and that would be row match. Is this actually the array that we want? Let's see. Now if we do a scanning, if we deshape this under this shape, then we do a scanning na sum. Yeah, scanning na sum. This should give us a progressive index. And now the problem now it lies in the fact that these numbers, what's the shape of this? It's odd. Okay. Sorry. Let's do a road up 1 dip road drop 1. So that there's shapes match. And a thing you can notice here is that we only want to put the indices on the where the numbers are, and since we have zeros on our mask earlier, okay, we can just multiply these. And then we'd actually keep their indices on where they are. That'd be nice, right? So we have a progressive index. And now if we, yeah, this is correct. So this is our progressive index. We put this here, and then that is that. So if we have an adjacency mask, their indices is type adjacency indices. If we shape both of these, that would be both the shape, and then we do a keep. Okay, we'll get the indices of where our adjacency mask collides with our indices. And if we do a deduct, we get that. And then let's these are one index right now, so we have to subtract 1. But also we should probably remove this 0. And how would we go about removing that 0? So it would just be duplicating this, maybe, and then sign, tapos keep. That's pretty neat. The reason for that working is we duplicate this and we do a sign. Okay, it turns 1 for positive numbers, and then -1 for negative numbers, 0 for 0. And if we use this mask to keep, okay, it actually discards the 0. So that's one way to do that. And then now we have our indices. Now if we subtract 1 to this would be indices from our numbers. And if we say select from n, okay, we get our numbers here. And then if we get the folding sum of this would be our answer. 4361. 4361. Now isn't that nice? Now I hope I was I wasn't too confusing on that because it's kind of like 6 a.m. and I haven't slept yet. But I would just wanted to talk about this problem. And I hope that was a good one. And keep staying curious or whatever. I don't have an outro.